Hi, we're looking at linear equations and graphs today. And Dave, we were wondering if you could take an equation and you would be able to tell us about the slope and be able to tell us the equation of the graph that we see.
Sure, I'd be glad to do that. Let's go ahead and take a look here at the paper. We've got the graph already up there, and we have several equations that it might be. So what's good to do is understand how do we interpret these. We've got y equals 2x plus 2. We've got y equals, it always seems to be y equals.
They look very similar.
They are, and this is a specific form that's good to know when you're doing algebra, and that's the form y equals mx plus b. Now that doesn't look like it would be very helpful. It actually seems more confusing now because now we have 4 variables instead of just 2. But what's nice is once it's in this form, we know what the numbers m and b represent.
Okay.
The m is actually for what we call the slope. I think of the word m for movement. How does this line move? It seems to be moving downwards.
Yeah.
So the slope would probably be a negative slope. And you can be more precise by actually figuring out how much you're going down as far as the y, which is the vertical axis. So we're looking for how, from this point, say right here, I want to go down. It looks like 1, so minus 1. And then to go over on the x-axis, it looks like I have to move over 2 spots. That'll be a positive 2. So I'm doing a down 1 over 2. That's called your delta y, which stands for change in y.
Okay.
And the plus 2 is what we call the delta x, or change in x. The delta is just a quick little symbol instead of having to write the word change. And that's really what slope is. A lot of people call it the rise over the run. It's just a quick way to remember the idea. But how much are you going up or down? Now in this case, the rise was a negative.
Okay.
So the delta y over the delta x is negative 1 because we went down 1, and then we had to go over 2 to get to the next point right there.
So with the y value, negative is downward.
Right, and up would be positive.
Okay.
And with x going to the right is positive, and going left is negative.
Okay, so just like on the graph here, to the right is positive, to the left is negative. So since we went to the right here, that would be a positive 2.
Right. And what's kind of neat about lines is, look, what if I wanted to go from this point to the next point?
Okay.
Let's try the same thing. It looks like I would have to go down, you switch colors.
Okay.
I would still go down 1 and over 2.
Okay.
Down 1 over 2, so it would be negative 1/2 again.
So the slope is the same here as it was for the previous point.
Exactly. If I do it again, go one more time, I come down 1 and over 2 and be at this point. So it seems to be little steps. You're going down 1 over 2, down 1 over 2, down 1 over 2, and that's called the rise over the run.
Okay.
Which will be written mathematically as negative 1/2.
Well, what if you tried to go, say, from this point here to this point here all in one jump? Would that slope still be the same?
That's a good question. Let's try that. I'm going to do that in orange. I'm going to come from this point here all the way over here, all in one step. So it looks like you have to come down to the x-axis, which is down 1, 2, where are we here? 3. And then we're going to have to move over 1, 2, 3, 4, 5, 6. So it looks like doing that big movement, we were going down 3 over 6.
That doesn't look like negative 1/2.
Well, actually, if you reduce your fraction, though, 3/6 is 1/2.
Oh, okay.
So if you do a bigger step, it should reduce still to the smallest possible step.
Okay. What if we go from one point up to another point? Are we still going to get the same slope?
Well, if you were to go up, so I can make a rectangle out of this, and then back, by going up, instead of coming down 3, what are we doing? We're going up 3.
So that'd be a positive 3.
But instead of moving to the right, which is a positive movement, now you're moving along the x, you're moving to the left, which is a negative direction. So we've put the negative now on the 6. So going the other way, so it really doesn't matter which way you read these. I always kind of look left to right because that's the way I read English.
Okay.
But you could look at it as up and back. So 3 over negative 6 still would reduce to negative 1/2.
So whether you go from one point to another, or take a step from one point and skip to 2 points,
or do all 3,
or even go uphill, if it's all on the same line, no matter where you travel from one point to another, we're always going to get that same slope?
Exactly. And this only works for lines.
Oh, okay.
This is a very specific formula to know for lines. This wouldn't work for a parabola or a circle or all kinds of different shapes you might run into. But for lines, they have a constant slope.
Slope is always the same.
So that's nice to know. So if we know it's y equals mx plus b, and we know that the slope, no matter how we looked at the points, was always negative 1/2, I could change this formula. Instead of mx plus b, I could put y equals negative 1/2 x plus b. Because we know that the slope is the negative 1/2. And that's probably enough clues to be able to tell the answer, but let's just finish this off. What does the b represent all this time? We know the m, for how it moves, is the slope. The b is what we call the y-intercept. Now, I don't know why you would pick the letter B for y-intercept. The thing I can think of, some people think maybe that's where the line begins.
Oh, okay.
It begins on the y-axis at this number.
Okay.
So looking at the graph, it's kind of hard to see our original graph there, but if you can see that line cutting through there, where did it hit the y-axis was right there at that point. And that point on the y-axis is at 0, 1, 2. So this line, if you think of this point right here being the beginning point, you begin on the y-axis. And that's because it's solved for y. It's y equals. If this had been x equals, then you'd be more concerned about the x-intercept.
Oh, okay.
But whenever you're in the y form, you want to use the y-intercept, which we know it begins at point 0, 2. X is 0, because you're right on the y-axis, and the y is 2. Well, it's just the 2 that we're interested in, not the 0 so much. So you just put the 2 into the formula, so you get the equation y equals negative 1/2 x plus 2. That would be the equation for this particular line, and that looks like answer C.
And you're saying that lines are usually written y equals instead of x equals?
That's just a tradition. There's really nothing magic about that. You could do x equals just as well. But traditionally we've been saying x is the domain. It's the number we put into the function, the input.
Okay.
And the output of the function is the range. And normally we've been calling that y. It's the x, y alphabetical, domain, range. And so I think that's why we solve for y, to make it the dependent variable. And x is considered the independent variable. So there's lots of vocabulary going on here. It's a fairly simple idea, but there's so many words. Slope, y-intercept, movement, beginning, domain, range, input, output. It's very easy to get confused on these.
So you've shown us how a picture of a graph, how it has a name, and that name of the graph we call the equation.
Exactly.
Great.